Hi, we're going to do number 39 from 8.2. That was on the homework. Like all of the volumes of Revolution, your first step is to draw the picture. So we have y equals e to the x, the x-axis, the line x equals 0, which of course is the y-axis, and the line x equals 1 for our area. So you don't have to be exact, but your sketch does need to be good enough so you can see what's going on. So here we have e to the x. Here, of course, is the x-axis. Here's x equals 0, the y-axis. And here's the line x equals 1. So the area that I'm looking at rotating is this area right here in orange, in between all those curves. So the visual is I'm taking that area and I'm going to rotate it, in this case, about the line y equals -3. So let's draw in y equals -3. The first thing I notice is the axis of rotation is not attached to my region, so there's going to be a big hole in the middle after I do my rotation, which means that I will have to subtract in order to get the proper area, or the washer method. The first step to come up with the sketch is draw a reflection. I'm reflecting it over y equals 3. So here's the reflection of y equals e to the x, would look something like that. And here's the reflection of my x-axis, something like that. So when I look at the reflected area, we're going to look at this region right here in blue. So that sort of would be my two-dimensional cross-section. So I can see that I've got the big radius is going to go from y equals -3. Your axis of rotation is always your center, all the way up to the line y equals x. This is going to be my large outer radius. My inside radius is going to still go from the center, from the line y equals -3 to the x-axis. That's my little radius. When I visualize the rotations, I notice that my cross sections, of course by rotations, are going to be circles. Since I'm stacking them up on the x-axis, the thickness is going to be my dx. So what I'm integrating here are all of these little figures, the washers, that have that kind of a cross section with a thickness of dx along the x-axis going from 0 to 1. I know that because they told me here that it goes to 1. So the area of that ring is going to be the outer circle, which is the large radius squared times pi, minus the inner circle, the little radius squared times pi. So now I go back to the figure for my expressions, and we get that the large radius is going to be the distance from e to the x to -3. So that's going to be e to the x minus -3 becomes +3, that whole thing squared. The little radius is the distance from the x-axis to -3, which is 3 units. So 3 squared all times dx. So I should have a dx up here too. And I can factor out the pi. So now when I expand and simplify this, I'm going to get pi times the integral from 0 to 1, e to the 2x, because that's e to the x squared, and then plus 6e to the x. And then 3 squared is 9, minus 9 will cancel out. And from there, I'm assuming you guys can finish up finding the antiderivative.